So now we're going to talk about issues with TDS, meaning you're running your system and you're expecting to get 0 TDS, 0 ppm out of your reader, and you're just not achieving that. So we're going to talk about everything that's involved with TDS issues and how to localize the problem. 9 times out of 10, when you see an issue with TDS, it means one of these filters needs changing. The issue is finding out which. Most importantly, we want to understand what our source TDS number is and how that translates through the system to see if we can find any clues to what's causing the problem. So, we'll start by running our system. And this is where your TDS meter will come into play. Each system comes with one. Now, these aren't hard to find. I personally recommend having more than one TDS meter. Why? It's technology. Technology can fail. It's good to have a second opinion. The last thing you want is to think you have a problem when it's a flawed meter and you just spend money on a filter. So it's important to have more than one TDS meter for accurate results. So let's see what our source TDS is. So we're going to measure that from the spigot. More than likely, you're going to have to disconnect your garden hose from the source. You'll fill the little container and then plug it into the meter. The TDS is not high here. I have 81 ppm. That's 81 parts per million. Let's see what the second meter says. Meanwhile, this meter is reading 74. So as you can see, you can have varying results. So first and foremost, the carbon filter. The carbon filter is something you're going to be changing more frequently than any other filter in this system. It's not the first thing to save TDS, but it's to prevent TDS. And I say that because you want the filter inside the metal housing to last the longest. So, start by changing your carbon filter. Now we're going to measure to see how well the membrane is performing. Now, membrane is going to take out about 90%, 99% in some cases of minerals in the water. It's highly dependent. You want to change this when it reaches 80%. How do we figure that? You'll take your source number. Mine was 81. We're going to see what we're getting out of this. Removing this hose from the DI inlet will result in a little bit of water splash. You can shut off your system to avoid getting splashed, or you can simply pull on the blue end of the push fitting and with the opposite hand pull the hose out. So now we're going to see how much of minerals have been removed from the RO membrane. We're just going to hook this back up. So from 81, brought it down to 6 ppm. Now it's not 0. That's what our third stage of filtration is for. Resin, the final cleanup. To verify, let's check the second meter. Second reader's around 9. Still close. Now, final stage of purification comes out of the resin chamber. Let's measure the quality of the pure water coming out of the system now that it has passed through carbon filter, RO membrane, and a 10-inch resin chamber. It's brought it down to 1 ppm. It's appropriate for cleaning windows. And I've received the same result on both meters. Now for theory's sake, we have 81 source, 81 ppm out of the source. And for some reason, this system is giving me 50 TDS. Now, let's figure out why we're getting that result. So we'll measure the DI resin. If I were to get the same result as I just did with this system, getting 6 ppm from 81 of the source, that's a high percentage of removal of TDS. It's not zero. That means this membrane is performing. Remember, it's taking like 90% of those minerals out. Let's say I get a result of 41 ppm from a source of 81 ppm out of the RO chamber. Right off the bat, that tells you that 50% of the TDS has been removed from the water. So at that point, that's an indicator that this membrane is no longer performing as it should, and it's time to replace. Now let's say theoretically, with the source 81 ppm, we get the result of 6 ppm, membrane is performing, but for some reason, outside of the system, we're getting 6 ppm. We're getting more ppm, we're getting 9 ppm. The issue is now localized to the resin chamber, meaning you must ask yourself, is the resin chamber properly situated? Is the resin chamber properly filled with resin? Lack of resin means lack of purification. If there's more room in that cartridge, then less of the water is going to get absorbed into the resin chamber. You also risk channeling by having too much water being able to pass through an area, a section of that filter, causing the rest of the resin to kind of harden. There, you're not going to see a good TDS result. So all in all, it'd be time to start with a fresh bag of resin, change out the chamber, fill it tight, and reseat it. If you receive 0 TDS afterwards, you know that the issue was just resin. It's time for a resin change. It's totally normal. Resin changes are also relative to how hard your water is, how many minerals are in your water. So if you're dealing with harsh water, like Arizona, Nevada, you're going to be going through carbon filters and resin changes more frequently. Keep an eye on that. As long as you're getting 80% more of removed solids from the water, from your reverse osmosis filter, you know the problem is not this. All in all, filter changes are important. So if you want your system to last longer, keep up with the maintenance.